Hello there. In this video I'm going to discuss about physics, IGCSE Physics Extended Paper 4. This is 42 February March 2020 paper. Okay, the time is 1 hour and 50 minutes. Okay, so we'll be going through the first question now. Okay, now a rocket launched vertically upward from the ground. The rocket traveled with uniform acceleration from rest. After 8 seconds, the speed is 120. So, what's the acceleration of the rocket? So, your formula here will be acceleration equals to velocity over the time. So, velocity we just have to put there 120 over the time, 8 seconds. Okay, how much is it?
15 minutes per second.
Yep, it's 15 minutes per second square. Don't forget this, per second square. So there's a small, okay, so this is a 2 marks for you. You okay with this first question? 1A done? Okay, next we move to the next question here. Okay, draw the graph for the motion of the rocket in the first 8 seconds. So now we just have to draw this. We just find the 8 seconds. This is 6, 7 and 8. 8 will be over here, and 120, this is 110, 120. So this is 120. So we just make a line here, and it is actually connected over here at this point, as you can see at this part, right? Okay, and then for this one you just have to draw a straight line. Okay, straight line. Make sure it is straight. This is not so straight because I'm drawing with a pen tablet. Okay, so this is your answer. Okay, this is 8 and here is 120 at this part. So make sure your coordinate is 8 and 120. You okay with that? So they just ask you to draw for the motion. So it's 1 mark over here. You got it?
Yeah.
Alright, let us move on. Okay, now we will go through the second question for B. This is B1. Okay, this one they'll be asking is use the graph to determine the height of the rocket at 8 seconds. So what you are given here is, let me make it correct. Okay, what you are given here is speed time graph, right? And then they ask you to find the height. The height is where you will calculate the area of this triangle. So given is a triangle area, right? 1 over 2 times with 8. Okay, this is the 8 and this is the 120. So we just have to calculate this. So you see how much you are getting there? You got 4. Yeah, so your height here will be 480 meter. Okay, this is the calculation for this. You okay, man? Yeah. Alright, okay. So the answer here for here will be 400 and also 80 meter as we discussed just now. Okay, now we are going to the last question for number 1. From time 8 seconds to 20 seconds, the rocket rises with increasing speed but with a decreasing acceleration. So from 20 to 25, the rocket has a constant speed of less than 200 meter per second. So draw for this motion, draw the graph. So how's this? So this one we have 2 different situation here, 8 to 20 and 20 to 25. Okay, so we'll, so 8 to 20, 20 to 25. Okay, so now, so as we all know that this part, okay, here's 8 and this one, okay, here's 8 and here is 120. So over here at this point, Okay, at this point we were getting a straight line, and then 8 seconds to 20 seconds, correct? 8 to 20 seconds. So what's the question there? Let us repeat. The rocket rises with increasing speed but with decreasing acceleration. So it means that if decreasing acceleration, you'll be getting a graph something like, wait a minute, okay, the graph will be decreasing gradient, but it's up to where, which point? So you can say the another graph here will be up to 20, 20. So you can actually mention like 20 is until here. So you can actually like going in this kind of curve, up to you, but make sure you don't reach 200. And then here will be a constant speed. If it's a constant speed, you'll be getting there until 25, right? Until 25, which is here, here, here. So will be here straight, right? So this is a constant speed. So this is a decreasing acceleration, decreasing acceleration, and here will be a constant speed. Okay, so you got this for this question. So your graph should be like this. Okay, all right, so this is the answer. Okay, now let us continue with the second question. So they mentioned that athlete crossing the finishing line in the race. As she crosses the finishing line, her speed is 10 meters per second. She slows down to speed of 4. So what is her impulse applied to her as she slows down? As she slows down. So you can say that impulse applied to her. So the impulse will be with the formula of Ft, correct? Ft equals to the change of momentum, mv minus mu. So the m, you can actually separate them, factorize the m, v minus u. Okay, so we just have to find for the, because it's impulse applied to her, it means applied to her. So we can say what is the final velocity over here. You can see.
Final velocity is 4 meters per second.
Okay, so 4, right? It's 4. So we just have to put here 71. The mass is 71, and it is 4 here minus with the initial, which is the 10, correct? Okay, now you calculate this one for me. So you'll be getting that. You'll be getting the answer. Okay, so it's supposed to be negative 426, but they already mentioned is applied to her. Okay, they already mentioned is applied to her, so which means negative will be absorbed. So you just have to put there 426. You can make sure you put the unit there. Unit for the force is Newton, and for the time is seconds, right? So we just have to put there Newton seconds. Okay, any question for this? Alright, so let us continue. So we just remember this. Okay, now the question for, okay, define impulse in terms of force and time. So what you can say with the formula? So we just remember is 426. Okay, now for the B, right? Okay, impulse, just now I got right here Ft, this is the impulse. Okay, this one is the impulse. So you can actually write in terms of force and time. Impulse is force multiply with time. That's your answer. Okay, this is just a very straightforward answer. So it's 1 mark over here. Okay, now number 2, at least take 1.2 seconds to slow down from 10 to 4. Average resultant force. Okay, we can use the first answer. What we get here is this answer we got here, 4 to 6, correct? So we just can apply it over here, 4 to 6 Newton seconds. And then how do we find the resultant force over here? So it will be, yes, mass times with acceleration. But that is another formula for the force. We just have to divide this 426, we divide it with the time. We are getting the force, right? So the time here will be 1.2. So you just have to divide this. So you'll be getting the answer 426 divided by 1.2. So you got the 355 Newton. That's your answer there, Finn. Okay, now calculate the force required to give a mass and acceleration. So this is way more easier because we just have to use the formula. Okay, this is, so we just have to use force equals to ma. So you'll be getting the 71. Okay, 71, then we multiply it with 6.4. Okay, calculate this. Four hundred and 400 and how much? 54.4 Newton. Okay, here's your answer. You got a total 8 marks over here for this question. Any question over here?
Resultant force and force, they have the same equation.
Resultant force and the force, they are actually the same. So because the, okay, when I write F equals to ma, correct? So this F must be a resultant force, or sometimes they call it as a net force. Okay, so it will give you the same answer. You got it, huh? Okay, so we will continue with the next question over here, number 3.
Number 3 still. Is it A1 is it 240 divided by 7.5?
Okay, there's a model of wind turbine used to demonstrate the use of wind energy to generate electricity. Okay, so we will have a kinetic energy over here. So what we can do, okay, we have turbine blade, circular errors swept out. Okay, this is circular error. We might have some mathematical calculation over here. Okay, first one, mass of air passing through the circular air swept out by the turbine blade each second is 7.5 kg. Wow. Okay, then kinetic energy of the air that passed through the circular area each second is this much. So how do we find the speed? So we can use this calculation here, 1/2 mv square equals to 240.
Answer should be D.
Then this 2 multiply here, you got there 480 divided with m. Divided with m is 7.5. And then don't forget your speed is square root here. Okay, can you calculate this? You got the 480 divided by 7.5. You got 64 there. So if you square root this, you are getting there around 8. Right? So it's just put the 8 meter per second. You okay with this question?
No.
Yeah, okay. So you got there 3 marks there. Okay, so they are asking here kinetic energy. State input power. Input power means power should be energy over the time. And you got that 240. This is the joule, initial joule, and this is for 1 seconds. So we are getting that 240 watt. Okay, 240 watt. You got it there, Finn? Okay, so that is your answer there for 1 mark. Okay, now we will go through again. Okay, they mention current, output current of the generator is 2. Current is 2 ampere. Output V, I mean the voltage here is 11. Output power. Okay, so what's your answer? So what's your answer there? Power VI. So it will be like 11 multiply with 2. So you'll be getting there 22. You okay? 22 watt. So this one is your output power. So your efficiency here will be power out over power in multiply with 100. So this is the formula. So power out will be 22 and your power in just now is calculated at 240, correct? And this is multiply with 100. So what's your answer here? So you'll be getting there. Yeah, so you'll be getting there 9.1666. So you can actually like round off this number to make it 9.2%. You okay with this? So that's the answer for the B, B1 and 2. So you are getting that 2 marks and 2 marks over here. Now let us go to the C. Okay, C. So what's your answer here? Now the density of air. Okay, density is mass over volume. And previously we know that mass, so you just calculate this part. This is 1.3. This is the density. They are asking for the volume passing each second. They are asking for the volume. Mass each second is a 7.5. Okay, we move here. 7.5 divided by 1.3. So how much is this?
1.769.
So you got the answer there. How you got 1.6.79? So here, oh, okay. So you got the answer there, 5.769. You can actually round off this to make it as 5.8. Okay, so that's your answer for this 2. Okay, so now for the 4th question, define specific latent heat of fusion. Okay, latent heat, you have to understand it is a no temperature change. Am I right? no temperature change over here. And then fusion refers to solid to liquid or liquid to solid. So how do you define it over here? So you can say thermal energy, okay, thermal energy required. This you can say like thermal energy. So I'll use a lot of short form over here. Thermal energy required for what? Required to change state of matter, to change state of matter. So I just put a short form over here, state of matter, okay, to melt solid to liquid, okay, solid to liquid without the change of temperature. So you just have to copy down the sentence, and here is your 2 marks. Okay, so now we will go to the calculation questions for B. Okay, now let us move on with 4B here. So here you'll be getting small piece of ice, 0 degrees Celsius, added to 0.35. Okay, you can see the initial temperature of the water is 24.5. Temperature of water decreases to 0. So you can see the change of temperature here is how much? Is you just like minus 24.5 minus with 0. Yeah, you are getting 24.5. You okay with this? This is a change of temperature. Okay, now specific heat capacity of water is given by the formula mc theta, and then here the mass is 0.35. C is what we are going to find here, specific capacity. Your theta here is 24.5. And then so you look at that, the water loses 35,000 of energy. So you just move here, move the mass and then move the theta to opposite side, becomes the divide. So C is 35,000 divided by 0.35 multiply with 24.5. Okay, calculate the C. So once we calculate the C, we are getting the answer around 4,000 4,081.6. Is it correct? 81.6. Okay, this one you have to remember the units as well. So the unit is joule, kg per kg. Just put a -1, and degrees Celsius -1. So you're getting that 2 marks over here. You okay? Okay, now is a further explanation regarding the units over here. So we just put there mc theta. You want to find the C, right? So this is the energy, mass theta. So if you notice that the mass and the theta here is actually, you are bring it above. So when you bring it above, yeah, you will have this -1 and -1 because it's bottom here. You are bringing it upward. You got it? Is kg and degrees Celsius. So once you bring it upward, it will become joule per kg and per degree Celsius. So this is the unit for the specific heat capacity. You okay? Okay. this is a mass of ice added to the water. So if you want to find, the energy will be the same. 35,000. So here will be, look at here. Okay, so what happens here? Mass of ice wadded, right? So it will be ml. This is the formula for this latent heat. So the energy will be the same. Okay, energy will be the same, 35,000. 35,000. And then the mass of water is what the question is. And then here the fusion, specific heat, latent heat of fusion is this. This is 3.3 10 to the power of 5. So this one will move there, it becomes divide. So try to divide this. Zero point. So you'll be getting the answer here is a 0.1. Actually should be 0.11 because the actual figure is 0.106 something, right? So you'll be getting the 0.11 kg. So this is the answer. Okay, so we have completed the fourth question over here. Now we are going to the fifth question. So you have any question over here you want to ask me? Okay, just go through everything. Okay, number 5, huh? Okay, now we are doing question number 5 here. Okay, if you notice that main process of thermal heat energy transfer. Okay, so we have here 3 things. One is a conduction. Okay, conduction is the energy transfer through solid. Okay, through the solid. And then we have a conduction. After conduction, we have convection. This is something like transfer of energy through the fluid. Okay, fluid means is air and also the gas. And the last one is radiation. Radiation is how we are getting the heat from the sun. That is the radiation from a hot object. Okay, so now we are going to fill up all this into this one. So a man goes for a walk on a cold day. He touches metal gate which remove thermal energy from his hand. So he touches a metal gate. So it should be a conduction over here. Okay. Finn, you got it? Okay. Then another one here. He holds the side of a cup containing hot rings. He hold, it means he is in contact. So his hand gains thermal energy by the same answer. You have a conduction over there. Okay, some farm worker have lit a fire. Okay, lit a fire. He warmed his hand by the side of fire. Of course, you cannot touch the fire, right? So fire will be like something like a BBQ camp. Fire will be in the center, and you will be like holding your hands, okay, in front of the fire. So here will be a radiation. Radiation. So that is your 3 marks over here. Okay. Then you number 5, B. In terms of particles, transfer the thermal energy through the metal of the gate after the transfer from man's hand. So how's this? So conduction, how conduction works? They are asking for elaboration for this part, this sentence. Okay. So normally, like when you have atoms over here, like in solid. So let's say this is a hot one, hot objects. So here you have the heat energy will be transferred from one to another atom. So what you can see over here is, here will be a electron movement. Okay, here will be a electron movement. Electron movement. Okay, you can see here electron movement. Okay, electron movement from atom to atom. Okay, from atom to atom. From atom to atom, that causes okay, so the answer for the 5B is this one. Okay, vibration of atoms to another atom, which will transfer heat or thermal energy. Okay, so we are focusing on this vibration of the atom, and then they will transfer to another atom. They'll vibrate. So that's how you can explain in terms of particles that transfer the energy. Okay, so this is for the 5B. You okay with this one? Alright, so next we move on with question number 5C. Okay, how's your 5C over here? You have an object A, windscreen, and then place inside the windscreen. Okay, it is used by the owner of the car to reduce temperature rise of the air in the car. So suitable object. So how is it, guys?
Shiny white.
Yes, correct. This is your answer, shiny white. And you can say your reason, because there is 2 marks over here, right? You can say it's a best reflector. Best reflector of the heat. You got it? Best reflector of heat energy. Okay, so this is the explanation. So you just have to explain this one and this one to get your 2 marks over here. You okay? Yeah. Alright. So let us move on with question number 6. Okay, question number 6, they are talking about a wave. Okay. So here, okay, draw 3 more crests to the right of the point A. So at the point A here will be okay, you can actually maintain. So you see this lambda, right? Okay, you have to maintain this, maintain the lambda, and then you can draw another one, make it slightly more longer, another one slightly more longer than the previous one, and here's like more longer. So you can see there is a curved part over here. There's a curve, it's going down. Okay, it's going down. So this is how you should draw this. State the name of the wave process that occurs as the wave passes point A. So this one will be your process diffraction. Okay, remember the name, diffraction. So in the wave phenomena total you have 4. One is a reflection, another one will be refraction. This one is going through the different medium like a glasses to air, and then you have a diffraction over here. The lastly, which is not much covered in the IGCSE exam, is the interference. Okay, it's the interference. This is not much covered in the IGCSE exam, so you can actually like ignore this. Okay, so we have done number A, right? 1 and 2. Okay, now we continue with the next question. Here, B. Okay, look at that. They're asking draw an arrow, direction of the movement of the wave. So this is the direction which is perpendicular. You can see that it's a perpendicular, right? So here you can draw the direction which is perpendicular like this. Make sure it's a 90 degree. This one is the direction of the wave, this part. You okay there? Okay. State the name of the process occur as the wave passes into shallow water. Different medium, you know. I mean, it's still water to water, but here is deep and here is shallow. So what happens is, here will be a refraction. So it will be refraction. So your B's answer, right? Okay, so you have done B1 and 2. So we move on with question number, the last one, number 3. Okay, what's your answer over here? So you just have to say property of the wave increase, decrease, or stay the same when the water passes into the shallow water. So deep to shallow, you have to understand one thing, deep to shallow. Okay, deep to shallow, the speed will be reduced. Speed will be reduced. So here will be decreases. Okay, another formula that I will pass it to you is, for this is only can be applicable for refraction. Speed, your lambda, your wavelength, and also your angle. So all here will be going down. If the speed goes down, everything will be going down. Alright, so your wavelength is also decrease. So your frequency for refraction will remains the same. So which is stays the same. Stays the same. Okay, stays the same. So this is your answer. This is for your 3 marks over here. Okay. Yeah, here, follow this formula. Just follow this formula. So if like a speed to shallow, speed will automatically reduce. If speed reduce, lambda will reduce, angle also will be reduced. Okay, but frequency will remain the same. You just remember this part. This is only for this refraction. Okay, this is only for the refraction. Okay, in case you have like this kind of question for number 7, I'll repeat again. Okay, draw the object. They have given you the image over here. This is the image, and you have to draw the object. So you have to draw 2 lines. Okay, 2 lines. One is, you can see the center. This is the center of the lens. Just take your ruler. You draw the straight line. Okay, my line is not so straight. I am using a pen tablet here. Just draw a straight line passing through the O here. This is number 1. Another one, I change the color. You have to pass through the B. Okay, pass through the focus point over here. Once you hit over here at this point, correct? You hit at this point, exactly at the center. You draw a straight line. You draw a straight line. Yes, so you can see this is where the object is. Okay, this is where the object falls. This is your object and this is the image. This is how you draw it. So remember how to draw this one. In case they give you the image and they ask you to draw the object. So this is the 3 marks for you. You okay? Okay, now we move on with the 7. I repeat again this one. Okay, ring all the following distance that are equal to the focal length. So this is the focal length over here, this part. Focal length. So your answer here will be A and C. AC and CB. That is your focal length. Okay, now we'll move to the next one. Okay, now it's a question 8. Now it's a figure 8.1 shows a circuit. Okay, the lamp has a resistance. Okay, these are the resistance R1. This is R2, 2 ohm, and this is R3. So XY represent uniform resistance wire of resistance 6 ohm. Reading of ammeter. Okay, how do we calculate the reading of ammeter over here? Yeah, so it's a 12. Just remember it's a 12 over here, 12 voltage. So reading of ammeter. So we can do the calculation over here. So we calculate the total resistance first. So it's all in series, right? So 6 plus 2 plus 3, you'll be getting the 11 ohm. And then here, so here will be V equals to IR. We are using the same equation over here. So the V will be a 12. We are going to find the current now. The resistance is 11. So 11 will move to the opposite side. So the current equals to 12 over 11 ampere. So this is your reading of the ammeter. Okay, can you calculate for me in your calculator here? So you got there, yes, so you got there, the answer will be 1.1 ampere, this part. So you got that, there are 2 marks there. So remember this simple calculation is the calculation of a series circuit. Okay, now we will go through again. This is A. Now we will do the B. Okay, this is the B. 8.2 shows the circuit, different connection, and added resistor. Whole resistance is 2. So here will be XY. The whole resistance wire is 2 meter. 2 meter. Okay. So now they ask us to calculate the resistance of the circuit. Resistance of the circuit. So the previously X and Y, you have there the total is a 6 ohm, correct? Okay, this 6 ohm is with a ratio. Okay, we just make a ratio. This is equals to 2 meter. Now if they reduce this to 0.6 meter, how much is your resistance over here, this part? So by calculating the ratio here will be, the calculation is 0.6 divided by 2. So how much you are getting there? You got there 0.3, correct? Okay, so 0.3. So you have to multiply over here this part. Multiply 0.3. So here the same thing, you have to multiply with 0.3. How much you are getting there? 6 times 0.3. You are getting there 1.8 ohm. So the resistance over here is a 1.8 ohm. So if you notice that here 1.5 and 1.8 is a parallel. It's a parallel connection. So 1.5, 1 over 1.8. So this is equals to 1 over R total. So we just solve this. Okay, we solve it. You'll be getting. So I'm getting here 129 still equals with 1 over R total. So 1 over R total equals to, here is 9, so it's 11 over 9. So R total here will be 9 over 11. Am I right? They have to invert. okay, you have to invert this. So because you have to find this R total among this part. Okay, and then you have to plus with the 2 and the 3. Yeah, plus with 5. So you'll be getting there, because this is a series connection. So your 9 over 11 plus with 2 plus with 3. Total up you'll be getting there. You got there 5.8. Okay. Yeah, you got the 5.8. So your total answer here will be 5.8. That is your 4 marks over here. Okay, so you already get your 4 marks here. Okay, next we will move to next question over here. Number 9 here. What's your answer for this? The first one. This is logic gates. Logic gates. So here will be none, because this one is an AND gate and it is being with a NOT gate over here. Correct? So this is a NAND gate. Most of the logic gate question for IGCSE is quite straightforward and simple. So it's 1 mark here. This one, name of the logic gates, you have only one input. So obviously it's a NOT gate, the triangle thing. Okay, this is another 1 more marks. Okay, now we move on to 9C. Okay, 9C, what's your answer there, Finn? Okay, so here will be okay, C, this is OR, this one is OR, and this is AND gate. So if you look at D, for it to get the output 1, you need to get 1 1. Am I correct? So if we search for the D, we search for the D. Confirm here is 1 1. The others can be 0 1 or 1 0. And you look at the C and D, right? So here will be 0 0. This is OR AND gate, and here is your NAND gate. NAND gate, you just have to follow this part. In case you forget the truth table for the NAND gate, AND gate here you have 1 1. Sorry, you just make it like 0 0 0 1 1 0 1 1. What's your answer there, Finn, for AND gate? Should be 0 0 0 1, right? If I put another NOT gate, it will become AND gate. So make it all opposite, 1 1 1 0. So here you'll be getting the 0 1 1 1. That's your answer. Okay, so you're getting the 4 marks here. So any question in this part? Okay, so let us move on with question number 10.
What was the thing again about all currents are like AC, and then to be safe to use becomes DC?
Okay, so this is alternating current. That is a rectifier, Finn. Okay, this alternating current, you have a changing magnetic field, because it is coming like positive negative, you know. This is the AC. So what describe magnetic effect of this alternating current? So what happens is, your answer can be magnetic field is being produced. Okay, being produced. So I'm using a short form over here. Magnetic field is being produced, and the magnetic field, it has a constant. It has constant. Wait. Okay, it has a constant changing magnetic field. Okay, constantly changing magnetic field. It means that magnetic field won't be steady, because you see, look at here the AC diagram. Here's positive, negative, positive, negative, positive, negative, right? They'll keep on changing. Okay, So that's what they ask you to explain over here. This is your 2 marks. This is for number 10. Got it, eh? Okay, come that next one. Okay, for the pan placed below the coil, above the coil. Now you can say the base of the pan is made of steel. So when you have a coil changing magnetic field, so what do you induce over here? Remember the one that I've taught you about this magnetic field, induced current. So the quantity is induced in this, the base of the pan over here, this part is, we call it as voltage. Voltage will be induced. So this voltage is the one that will change to thermal energy and will heat up the water. Okay, now you go to C, this part. You can say effect, state and explain the effect of quantity induced in part B. So what happens here is, you can say voltage and current induced. Okay, voltage and current induced and increase the temperature. And increase the temperature of the water by producing thermal energy. So that is the answer for your C here. You okay? So it's a 3 marks over here. You just have to explain the things. Okay, now let us move on with the question, the last question over here, number 11. Okay. Okay, number 11 over here, isotopes. Isotopes, okay, isotopes of hydrogen. Okay, hydrogen normally they'll have one over here. Okay. So at this part, as a proton number, okay. Another hydrogen they can mention over here, proton number is 1, nuclear number is 1. Okay. Helium, isotope, helium is this. Helium is, okay, here for your information at this part, this one, okay, let's say I just write it bigger over here. Okay, this is 2. This one is more to a proton number. Got it? This is a proton number. This one will be a nucleon number. Nucleon means is a proton plus with neutron. This is one is only for proton. So now the proton will be equals to electron. So to get your neutron, you have to minus both of these. So how much we are getting over here when we minus? They want the neutron. Just minus this, we are getting 1 here, correct? 1, and then helium. Okay, helium 4, they have mentioned there. So just like minus this one, you got that 2. Okay, electron, they will follow the proton number. Proton number we just have to find. Okay, look at helium 2, you got that 2, right? So just put that 2. Helium 4, you refer to this one. Okay, so you'll be getting there, here's 2, your answer. Okay, comparing 3, 4. So here will be 3 and 4. Mass compared to neutral atom of hydrogen 1. Okay, so an experiment takes place in a laboratory shield from all background radiation. A sample material is wrapped in 0.1 mm. A detector of ionizing radiation placed 1 cm from the foil. A piece of aluminium of thickness 5 mm is placed between detector and the foil. The detector reading drops to 0. So state and explain any type. So any type of radiation passing through aluminium foil. So it can be, the only choice here, radiation we only have alpha, beta and also gamma. Gamma is impossible to be included over here because it can only be stopped by a thick lead block. So alpha can be stopped by 0.1 aluminium foil. Okay, however, this beta can be stopped by 5 millimeter of aluminium. So there is only these two rays exist in this experiment B, and this explanation will give you 3 marks over here. So we have ended the paper with this question. All the best for your IGCSE. Thank you.